In this video, we're going to look at everything you need to know for Cambridge A's Level Mathematics 9709, Pure Mathematics 1, Arithmetic and Geometric Progressions. Let's start with Arithmetic Progressions. For any series, Tn is the value of the actual term, while n is the position of the term. Always keep this in mind. This will help you to see what you have and what you need to find. When working with an arithmetic series, we can use the formula Tn is equal to a plus the bracket n minus 1 multiplied by d. Here, Tn is the value of a given term, a is the value of the first term, n is the position of the term, and d is the constant difference. We can use this formula to find an unknown term. An arithmetic series has a constant difference between each term. This means that the difference d is equal to the value of a term minus the value of the term directly before it, or the value of a term plus the difference d gives us the value of the term directly after it. Let's look at some examples of arithmetic progression. For the following sequence, find the nth term. To find the nth term, we need to use the formula Tn is equal to a plus the bracket n minus 1 multiplied by the constant difference of d. A is our first term, and in this case we can see that a is 1. You can say a is 1. D is the difference between any two consecutive terms. So let's look at the first and second term. You can say D is equal to, the second term is 6 minus the first term, which is 1. And we see that D is equal to 5. Now in our formula, we can say that Tn is equal to A, which is 1, plus the bracket of n minus 1, multiplied by the constant difference of 5. Let's expand our bracket. We get 1 plus 5n minus 5. To add like terms. And for Tn, we now have the equation of 5n minus 4. Let's do another one. Determine the 30th term in the sequence that begins with 65, 60, 55, and so on. Again, let's write down our formula. Tn is equal to a plus the bracket of n minus 1 multiplied by d. To find the 30th term, our n values will be 30, but to find the actual value, we first need a and d. A is the first term, 65. Say a is 65. Let's find the constant difference d. Say d is equal to the second term, 60, minus the first term, 65, which gives us negative 5. Now we can fill these terms into our formula. We want the value of the 30th term. We can say t 30 is equal to a 65 plus n is 30, so n minus 1 becomes 29. 29 multiplied by d, negative 5. Now you can take your calculator. You can say 65 plus 29 multiplied by negative 5 is equal to negative 80. This is the value of the 30th term. Let's do another example. Determine which term in the progression is equal to negative 39. In this case, we are looking for the position of the term. So we are looking for n. Let's start with our formula. Tn is equal to a plus the bracket n minus 1 multiplied by d. Here we are given the value of the term. So in this case, Tn is equal to negative 39. A is the first term, which is 15. So A is 15. Let's find the constant difference D. We can say D is equal to 12 minus 15, which gives us negative 3. Now we can fill in our values. We have the value for the term, so that's Tn, so say negative 39 is equal to A, 15, plus the bracket of n minus 1, multiplied by the constant difference D, which is negative 3. Let's expand our bracket. We have negative 39 is equal to 15 minus 3n plus 3. Now we have negative 39 is equal to 15 plus 3 is 18 minus 3n. Let's make our n term positive. So let's move it to the left. We now have 3n is equal to 18 plus 39. Let's take my calculator. 18 plus 39 is equal to 57. Now I can divide both sides by 3. Divided by 3 is equal to 19. So in this case, negative 39 is the 19th term. Let's do one more. The fourth term in an arithmetic progression is 14, and the 16th term is 50. Calculate the 15th term. Let's start by making some notes. We know that the fourth term is 14, and the 16th term is equal to 50. But remember that an arithmetic progression has a constant difference between their terms. So from term 4 plus the difference gives us term 5, plus the difference gives us term 6, and so on. So in this case, let's see how many terms we have between the fourth term and the 16th term. So I can say 16 minus 4 is equal to 12. This means that we need to add the constant difference D 12 times to term 4 in order to get term 16. This is going to allow us to find the value of the difference. So now I can say the term 4, 14, plus 12D is equal to the 16th term, which is 50. Let's move 14 to the right. I have 12D is equal to 50 minus 14, which is 36. Divide both sides by 12, and we see that D is equal to 3. We know that the 16th term is 50, and the question asks us to find the 15th term, which means we want the term directly in front of it. And we know that if we have the value of a term and we minus the difference, we will get the value of the term directly in front of it. So in this case, I can say the 16th term, 50, minus the difference of 3, is equal to 47. This is our 15th term. Now I'd like to look at how we find the sum of an arithmetic series. To find the sum, we can use this formula. But please remember, the sum only counts the first n terms. We can find the sum of the first 10 terms, or the first 5 terms, or even the first 5 million terms. This formula allows us to count whatever number of terms from the first term onwards. But because of this, you need to be careful. If you want the sum of 10 terms, it will be the first 10 terms. You cannot randomly decide which 10 terms you want to count. Let's look at some examples of how we work with the sum of an arithmetic series. Determine the sum of the first 30 terms in the series. Let's start with our formula. We have Sn, the sum of n terms, is equal to n over 2, open a bracket, 2a, plus smaller bracket, n minus 1, multiplied by d. The question asks us for the first 30 terms. So in this case, n is 30. A is the value of the first term. So in this case, a is 3. To find the constant difference, let's look at the first and second term. So we can say d is equal to the value of the second term, 8, minus the first term, which is equal to 5. And now we can put these values into the formula. So we can say the sum of 30 terms is equal to 30 divided by 2, that's 15, open a bracket, 2 multiplied by 3, plus n is 30, so n minus 1 becomes 29, multiplied by the difference of 5. Now I can take my calculator. I'm going to say 2 multiplied by 3 plus 29 multiplied by 5. Let's multiply this by 15 is equal to 2,265. This is the sum of the first 30 terms. Let's do another one. Determine the sum of the series 35, 32, 29, all the way down to 5. Before we can find the sum of these terms, we need to determine the number of values in the series. And to do this, we need to find the position of this 5. So we need to start with an arithmetic progression. Tn is equal to a plus the bracket of n minus 1 multiplied by d. To find the position, we need to find the value of n. We're looking at this last term, 5. So Tn is 5. The first term is 35. So A is 35. The constant difference, let's say the second term, 32, minus the first term, 35, is equal to negative 3. Now I can put these values into the formula. We have 5 is equal to 35 plus the bracket of n minus 1 multiplied by d, negative 3. We're going to get 5 is equal to 35 minus 3n plus 3. Now we have 5 on the left is equal to negative 3n. 35 plus 3 gives us 38. We need to solve for n, so our n term needs to be positive. Let's move it to the left. We now have 3n is equal to 38 minus 5, which means that 3n is equal to 33. Divide both sides by 3, and we see that n is equal to 11. This is the position of our 5 up here, which means we need to find the sum of the first 11 terms. So I'm going to make a note that n is 11, and now I can make some space. To find the sum of 11 terms, I can say Sn is equal to n over 2, bracket 2a plus n minus 1 multiplied by d. Now we can fill in our values. N is 11, so we can say the sum of 11 terms is equal to 11 over 2, open a bracket, 2 multiplied by a, which is 35, plus n is 11, so n minus 1 becomes 10, multiplied by d, negative 3, and close this bracket. Now I can take my calculator. I'm going to say 2 multiplied by 35 plus 10 multiplied by negative 3 is equal to, now I can multiply this by 11 over 2 is equal to 220. This is the sum of the 11 terms. Let's do one more example. Determine how many terms in the series 5, 8, 11, and so on must be added to get the sum of 440. We are working with a sum, so we need to use the formula Sn is equal to n over 2, open a bracket, 2a plus the bracket of n minus 1 multiplied by d. The question tells us that when we add the terms together, we get a sum of 440. This is the value of the sum, Sn. So over here, I can say that Sn is equal to 440. The question wants us to find how many terms are added. So we are looking for the value of n. To find n, we first need the value of a and the value of d. A is the first term, which in this case is 5. We can say a is equal to 5. Let's find the constant difference d. Let's use the first two terms. We can say d is equal to 8 minus 5, which is equal to 3. Now we can put these values into the formula. So we have 440 is equal to n over 2, open a bracket, 2 multiplied by a, which is 5, plus n minus 1 multiplied by d, which is 3. Now we can expand the brackets. We have 440 is equal to n over 2, open a bracket, 2 multiplied by 5 is 10, plus 3n minus 3. We want to solve for n. So let's multiply both sides by this 2. On the left, we're going to have 880 is now equal to n. In our bracket, let's add like terms. We have 3n. 10 minus 3 gives us 7. Now we can multiply the bracket by n. We get 880 is equal to 3n squared plus 7n. We are working with a quadratic, so in order to find the value of n, we need to make this equation equal to 0. So I'm going to make some space, and I'm going to rewrite our equation up here. 3n squared plus 7n minus 880 is equal to 0. When solving for a variable in an equation that is a quadratic, the easiest way is to use the quadratic formula. N is equal to negative b plus or minus b squared minus 4ac under a square root all over 2a. In this case, b is 7, so we get negative 7 plus or minus 7 squared minus 4 multiplied by a, which is 3, multiplied by c, negative 880 under a square root all over 2 multiplied by 3, which is 6. Now you can use your calculator to find the value of the root. So I can say 7 squared minus 4 multiplied by 3 multiplied by negative 880 is equal to, let's square root, and we get 103. So now we can say negative 7 plus or minus 103 all over 6. N is the position of a term, so n will always be positive. So with this equation now, we only consider the positive root. So we only consider the plus sign. So to find n, I can say -7 plus 103 divided by 6 is equal to 16. So n is equal to 16. Now I want to look at geometric progressions. When working with a geometric series, we can use the general formula Tn is equal to a multiplied by r with an exponent of n minus 1. Here, Tn is the value of the term, a is the value of the first term, n is the position of the term, and r is the common ratio. Please remember that in this format, we never multiply a and r together. In a geometric series, we multiply each term by a common ratio. But remember that if our terms get smaller each time, we are not dividing, but rather multiplying by a fraction. To find the common ratio r in a geometric series, we can use the formula r is equal to Tn divided by Tn minus 1. So in other words, we can take the value of any term and divide by the term directly before it. Let's look at an example. Find the 10th term in the following geometric progression, 10, 30, 90, and so on. Let's start with our formula. Tn is equal to a r with an exponent of n minus 1. We want the 10th term, so n is 10. A is the value of the first term, which is also 10. To find the value of r, we take any term and divide by the term directly in front of it. So let's look at 30 and 10. So r is equal to 30 divided by 10, which gives us 3. Now we can say the 10th term is equal to 10 multiplied by r, which is 3, with an exponent of n minus 1. N is 10, so n minus 1 becomes 9. Now you can take your calculator, and we say 10 multiplied by 3 with an exponent of 9 is equal to 196,830. 196,830. This is the 10th term in the progression. Let's do another one. Consider the sequence below and find the 11th term. Again, let's write down our formula. Tn is equal to a multiplied by r with an exponent of n minus 1. We are looking for the 11th term, so n is 11. Our first term, a, is 1, so we say a is 1. To find the common ratio, let's divide 1 over 2 by 1. And when you divide anything by 1, the value remains the same. So r is equal to 1 over 2. Now we can say that the 11th term is equal to 1 multiplied by r, 1 over 2. Let's put that into a bracket. N is 11. 11 minus 1 gives us 10. When you multiply any value by 1, it remains the same. So in this case, we can take our calculator. Let's open a bracket. You can say 1 over 2 with an exponent of 10 is equal to 1 over 1024. Let's do one more. The third term in a progression is negative 110. The sixth term is 32. Find the common ratio and the first term. So let's see what we know. The third term is negative 108. So we could say that term 3 is equal to negative 108. And the sixth term is 32. In a geometric progression, there is a common ratio of r between our terms. That means that if I take term 3 and I multiply by r, I get term 4. Multiply by r, I get term 5. Multiply by r again, I get term 6. I can use this to find the value of r. Term 3 is negative 108. Multiply by r 3 times, I'm going to multiply by r cubed, is equal to term 6, 32. Now to get the r term by itself, let's divide both sides by negative 108. So r cubed is equal to 32 over negative 108. Take your calculator. 32 divided by negative 108 is equal to negative 8 over 27. This is r cubed, but to find r, I can cube root. So now I can say cube root, my answer, is equal to negative 2 over 3. This is my r value, negative 2 over 3. The question also wants us to find the first term. And we know that the first term multiplied by r gives us the second term. Multiplied by r again gives us the third term. So term 1 multiplied by r squared gives us our third term. To get term 1 by itself, let's divide both sides by r squared. Term 1 is equal to term 3 over r squared. We know that term 3 is negative 108. We now know that r is negative 2 over 3. So let's square this. Now I can take my calculator and I can say negative 108 divided by negative 2 over 3, close the bracket, squared, is equal to negative 243. This is my first term. Now let's move on to the sum of a geometric series. To find the sum, we can use the formula. The sum of the terms is equal to a multiplied by the bracket 1 minus r with an exponent of n, all over 1 minus r. Tn means the value of the term. So Sn is the sum of the terms. Please just remember that r will never be equal to 1 because this will make the fraction undefined. So let's look at an example. Find the sum of the first 8 terms of the sequence negative 5, 15, and so on. We are looking for the sum of 8 terms. So n is 8. Let's write down the equation for the formula. The sum of n is equal to a, open the bracket, 1 minus r with an exponent of n, all over 1 minus r. We know that n is 8, but to find the sum, we still need the first term and the common ratio. The first term is negative 5, so a is negative 5. Let's find our ratio. Let's use the first and second term. You can say r is equal to 15 over negative 5, which gives us negative 3. Now we can put these values into the formula. We can say the sum of 8 terms is equal to a, negative 5, open a bracket, 1 minus, r is negative 3, so negative 3, with an exponent of n, which is 8, over 1 minus negative 3. And you can put this straight into your calculator. Let's create a fraction. We have negative 5 let's open a bracket, 1 minus bracket of -3 with an exponent of 8. Close the bracket, over 1 plus 3 is equal to 8,200. This is the sum of the first 8 terms in this progression. Let's do another one. Determine the sum of 9, 3, 1, and so on to 7 terms. Let's start with our formula. Sum of n terms is equal to a, open a bracket, 1 minus r with an exponent of n, all over 1 minus r. We are looking for the sum of 7 terms. So n is 7. A is our first term, 9. The a is 9. Now let's find our common ratio. Use the first 2 terms. R is equal to 3 over 9. Now, in your exam, you can simplify this fraction, but you do not have time to waste. So in cases like this, let's leave our R value as it is. Now I can say the sum of 7 terms is equal to 9, open a bracket, 1 minus, open a smaller bracket, 3 over 9, with an exponent of n, which is 7, close this bracket, all over 1 minus 3 over 9. Take your calculator. Let's create a fraction. We have 9, open the bracket, 1 minus 3 over 9, close that bracket, with an exponent of 7 over 1 minus 3 over 9 is equal to 1,093 over 81. Now I want to look at the sum to infinity of a geometric series. We can add an infinite number of terms in a geometric series, and we will never get past a specific value. When an infinite sum converges, it gets closer and closer to a certain value, but never reaches it. Remember that when working with converging geometric series, your common ratio R will be greater than -1, but smaller than 1, but will never be equal to 0. To find the sum to infinity of a geometric series, we use the formula. The sum to infinity is equal to a over 1 minus r. So let's look at an example. A geometric progression has first term a, and common difference r is 0,9. The sum of the first 5 terms in the progression is 409,51. Part A says determine the value of a. The question tells us that the sum of 5 terms is 409,51. We can use this to find the value of a. So we're going to use the formula. Sn is equal to a, open a bracket, 1 minus r with an exponent of n, all over 1 minus r. The sum is 409,51. This is the value for Sn. 409,51. The question tells us the common ratio r is 0,9. So r is equal to 0,9. We're looking at the sum of 5 terms. So n is 5. So now we can say at 409,51 is equal to a, open a bracket, 1 minus 0,9 with an exponent of 5 over 1 minus 0,9. We need to find the value of a. So we need to make a the subject. The easiest way to do this is to rearrange the formula. Let's put the denominator into a bracket. And now we can multiply both sides by this bracket. Going to have 409,51 multiplied by 1 minus 0,9 is equal to a multiplied by 1 minus 0,9 with an exponent of 5. To make a the subject, let's divide both sides by this bracket. We're going to get 409,51 multiplied by 1 minus 0,9 all over the bracket of 1 minus 0,9 with an exponent of 5. And this is equal to a. Now you can simplify the values within the bracket, but then you have decimals and it becomes more difficult. So the easiest thing to do now is to put this entire fraction into your calculator. Let's create a fraction. We're going to have 409,51 multiplied by the bracket 1 minus 0,9 over 1 minus 0,9 with an exponent of 5 is equal to 100. So a is equal to 100. And now we can look at part B. Find the sum to infinity. To find the sum to infinity, we use the formula a over 1 minus r. We now know that a is 100. And we know that r is equal to 0,9. So to find the sum to infinity, we're going to say 100 over 1 minus 0,9. Take your calculator. 100 over 1 minus 0,9 is equal to 1000. This is the sum to infinity.